Hi, my name is Shakota Johnson. I'm going to explain the second part of homework 6. Here, well, let's start with the ALU. I have the same ALU. Since we were able to choose our conditions, the only two conditions I will be choosing are to add and subtract, but this stayed the same from the first explanation. The FSM, which I named FSM2, of course, I had to make sure that I process the feedback signal because I do want to note that the ALU is going to perform an operation and it's going to output a 4 bit number, and that 4 bit number is going to be the feedback input signal for our FSM. And right here is just basically when I'm checking if the least significant bit is a 1, then I want it to give an add input into the ALU for the next operation. And if it's odd, I want it to subtract. So that's my FSM. My top level stayed relatively the same as well. It still operated the same way, only now we have a temp2 signal for an output because we had to add another output for that feedback to connect all of our components. Okay, so the FSM is still connected to the ALU, but now the ALU is connected to the FSM as well as I aforementioned. So my test bench, I'm just explaining what the next waveforms are going to do that I'm going to show you. Um, I gave 3 cases. There's 8 and 1. When you add 8 and 1, because of course it's going to initialize to 0, 0, and my 0, 0 is adding. So that's the first thing you're going to do with every single one of these sets of numbers. So 8 plus 1 is 9, and 9 is an odd number. So it's going to output the sum of those two numbers, which is 9. Okay, the second case is 8 and 2. 8 plus 2 will give you 10. 10 is an even number, so it will subtract 2 from 10, and we should output, excuse me, sorry, not a 10. This is an 8. An 8 an 8 plus 2 will give you 10. And 10 is an even number, so it's going to subtract 2 from 8. Excuse me, sorry about that. And then this third case is 2 plus 1. Gotta fix that. Is 2 plus 1, and which will give you 3. And 3 is an odd number, so it's going to add. So as we can see in our waveforms, I went ahead and ran it for 2000 nanoseconds. As you can see right here, when the input was an 8 and a 1, it gave me the output of a 9 as anticipated. When it was 8 and 2, remember you add those two numbers together. 10 is an even number, so we subtracted 2 from 2 from 8, and that's how I got 6 right here. And then the last test case was 2 and 1, and we added 2 and 1 together, and it equaled 3. 3 is an odd number, so they added the two numbers together, and that's how they got 3. 2 plus 1 is 3. That's pretty much it. Besides the whole mix-up about the 8 and 10, I do want to make it clear that this is 8 plus 2 giving 10, and 10 is even, so you subtract 2 from 8, and that's how you get 6. Thank you.